Bismillah ar-Rahman ar-Rahim. Today we start our lecture in continuation with the previous lecture regarding first order logic. So here we will talk about truth in first order logic. How we will determine the truth value. Syntax is, we have already discussed, means the representation of the sentences. Now we want to see the truth in how to evaluate truth in the first order logic. So in a FOL, always remember that the sentences are true with respect to a given model and an interpretation. When I say a model, it means which situation you want to reflect. For example, in this, I'll show you the model. For example, in this is a model, and in this model, whatever the interpretation you find out, you represent the sentences. So if you want to represent anything which has no interpretation in the given model, that will not be true in the given circumstances. So here it is important that whenever you're representing any situation or a model, you have to take that model and an interpretation into the context. For example, if I ask you to represent the FOL statements of the Bumpers world problem, which we have discussed in the last chapter. So that model is changed. Then you represent the sentences with respect to that particular model. Or let's suppose if I take another example, let's suppose if I ask you to take the kinship domain, your family domain, and represent those sentences in FOL, then the model is different. So sentences are true with respect to the given model and an interpretation. For example, you see this model. So here R and J are brothers. But let's suppose if I give you one statement over here that J and Crown are brothers. So what do you think? With respect to the given model, is it true? The answer is no, it is false, because the crown is not a person. So the brother relationship exists among the persons or the individuals, and therefore in the given model that relationship does not exist, or you cannot interpret in this manner how I have interpreted the sentence. So similarly, if I want to say that R is on head of John, again in the given model and in the given interpretation, it is wrong. You will say that that is not a right sentence. Although, as far as syntax is concerned, you can construct such a sentence. But it is important that we have to evaluate those sentences and to see that whether those sentences are true in the given model, the given interpretation, or no. So that is basically the how we evaluate the truth value. Interpretation specifies reference for constant symbols, normally for objects, predicate symbols for relations. As I told you earlier, the function symbols are also called function relations. Now you can say an atomic sentence is true. When it will be true? An atomic sentence is true if and only if, IFF always represents if and only if the objects referred to by term are in the relation referred to by the predicate. So all those objects who are referring those terms must be there in the relation. If it is not the case, then the sentence is not true with respect to the given model and an interpretation. So that is important about FOL. Now we'll move towards the use of universal quantifications or universal quantifiers. So there are two quantifiers, one is called for all. So here we will see that how you can use for all in the sentences. So whenever you use for all in a sentence, you have to write a sentence in this manner. Here you can see that you have, first of all, the quantifier, that is for all. Then the variables, how many variables will be there? Maybe one variable or maybe more than one variable. And then you have the sentence. That is the representation of for all. For example, we have a given statement that all kings are persons. Okay, all kings are persons. This is true. and this is a universal truth. So how we represents all kings are persons? So it means the individual who are persons, those who are referring to as kings, you can take it as a variable like x. So you can say for all x, which x we are referring to? Those x who are king. So that representation in the form of the predicate will be king bracket x, implies all those x are also persons. Why? Because this is in the statement, all kings are person. This implies that all x are persons. So that representation is in FOL right now. The sentence is given in the natural language in English that all kings are person, and for all x, king s implies person x is the representation in FOL. So you can see, you can understand the concept of the for all, and you can say that for all xp is true in a given model M, if and only if p is true with x being each possible object in the model. Let's suppose I've given you the example of statement regarding marks. So all students of AI have cleared the exam or are passed in the exam. So it means we are referring to student and we will refer it like X. So for all X, okay, we are referring for all X, student bracket X, because those X are students. So we can write student bracket X implies, ठीक है, all those are pass. So implies pass bracket X. So it means that is the representation. Let's suppose if I want to say that every every individual individual has has a parent. Every individual has a parent. So this is again is a universal statement. But here there are two variables involved. One is that individual and the other one is called the parent. But in the given statement right now, only one variable is involved. So we can see both the examples by using single variable or more than one variables. So if I say for example, everybody likes ice cream. So every individual likes ice cream. Everybody likes ice cream. Again, the quantifier which we'll use will be for all. So for all x likes x comma ice cream. Now here the like is the predicate, x is the individual, and x likes the ice cream. So x comma ice cream implies there's no need of implication. This is enough. For all x likes x comma ice cream means every individual likes the ice cream. So in that manner we can use the for all operator. If we do not have the for all operator, in other words, you can say it is the conjunction of all the instantiations. So it means we can say that, for example, student seat number 101 is in AI and he is pass, and student 103 is in AI and is pass, and student 104 in AI and is, it means actually that sentence represents the conjunctions of all the instantiation of the given P or a model or a situation, so or a fact or a sentence. So it represents, so it is, you can say it is the conjunctions of all the instantiations. That is called universal quantifier. Normally, whenever we use the universal quantifier, whenever we go for the conclusion or whether we want to say or interpret something, we use implication. Like you see in this example, for all x, king x implying person x. So here what are you using? You imply that for all x, king x imply person x, so person x. So it means that is, again, normally whenever we are using the universal quantifier for all, we use implication. And the other quantifier is called the existential quantifier. The existential quantifier is represented as, you can see, with this symbol. Then you have again the same thing, variable, maybe one variable, maybe more than one variable, and then the sentence. For example, the sentence is that the King John has a crown on his head. So it means it is not true for everyone. King John has a crown on his head. So here we are referring to the as existential quantifier, or there exist. Then we have the variable, the crown X, and on head, that X comma John. It means it is on the head of the John. So there is always a crown which is called crown X, and it is on the head of the John. So here we have used the existential quantifier, and instead of using an implication, here we have used and. So normally whenever we are using existential quantifier and we are making an conclusion, or you can say, you can imply certain thing, there you will use and operator, not the implication. But with the for all, you use implication. So you can say, in other words, that there exists P is true in a given model M if and only if P is true with X being some possible object in the model. For example, if I say few students in this class are a few students in this class are absent. So here I am referring to some of the students. I am not referring to all of the students. So here I can write existential quantifier to represent the statement. If you, in other words, you can say that the existential quantifier is actually the disjunctions of all the instantiation. Because here you can make a statement, then or, then again the statement, then or, and so on and so forth. And you take all the objects which are defined in the given model. So for all is basically the conjunctions of all instantiations, and the existential quantifier there exists is the disjunction of all the instantiations. That is the difference between these two. And now you can see this slide which represents the properties of quantifiers. So obviously when we talk about quantifiers, they have various properties, and we have to understand those properties. Number one, if any sentence involving two variables and both variables are basically represented in terms of for all, so normally we say for all X, for all Y, is the same as for all Y, for all X, because it is true for all Y with respect to all X, or it is true for all X with respect to all Y. So in that manner, both the representation are true. Similarly, if you write a statement, there exists X, there exists Y, is the same as there exists Y, there exists X. So there is no problem in defining, but remember, you can also use mix of these quantifiers. It means a quantifier, one quantifier might be representing the existential one and the other one is representing the for all. So you cannot say that there exists for all Y is same as for all Y there exists. In this condition, it will not hold. And you can represent various statements by using multiple quantifier. Here you can see that there is one statement that there is a person who loves everyone in the world. Okay, there is an individual or there is a person who loves everyone in the world. So it means we are referring to a person and who loves everyone. So the other side, there is also an individual. So we are talking exactly about two individuals. One is called X, the other one is called Y. So there exists X because there is a person. Statement, if you see the statement is not like this, that all the persons who loves everyone in the person, or every person who loves everyone in the world. No, this is not the statement. The statement is there is a person. So we are referring to a specific person, might be not all the person. So for a person we use existential quantifier, and because he loves everyone in this world, so for the other object we use y, and for that purpose we have for all. So there exists for all y loves x comma y. So that is the representation. And you can see that if you change the quantifiers positions, the meaning of the sentence will change. It will become that everyone in the world is loved by at least one person. So quantified duality is another important thing to understand. There is one statement written over here, and that statement is the representation of everybody likes ice cream. So this is a statement. Everybody likes ice cream. It means it's a universal statement. It's true for everyone. So for all x likes x comma ice cream. Yes, this is true. When I say duality, duality refers to the expression in other form, or normally we call it dual expression. For example, sometimes we say that half glass is empty. The dual expression is that the half glass is full. Okay, although as far as sentences is concerned, there are two different sentences, but both sentences give the same meaning. So here the duality principle also applies to for all and existential quantifiers. And if you want to represent the for all statement in existential quantifier, or you want to represent the existential quantifier statement in a for all quantifier, then you have to negate the quantifiers and you have to negate the expression. For example, in the first statement you can see for all x likes x comma ice cream, and you want to have a dual expression. And whenever you want to have a dual expression, it means you want to represent this as an existential quantifier. So here you can see that is in the statement there is a not there exists x, and for the sentence there is also a negation, not likes x comma ice cream. इन उर्दू वी कैन से कि सबको आइसक्रीम पसंद है, और इसका जो डुअल स्टेटमेंट बनता है कि कोई भी नहीं है जिसको आइसक्रीम पसंद नहीं है. So everybody likes ice cream. There is nobody who doesn't like ice cream. So both statements are true, and these statements are called dual statements or quantified duality. We call it quantified duality. Now you can see various sentences and you see how you can represent it in FOL. So I will give you a hint how you can convert this into FOL, a statement into an FOL statement. So whenever you have been given various statements or a model to represent it in FOL, in the first step, try to identify the objects which are involved in the statement. Number one. Maybe there is only one object involved, maybe there are two objects involved, and maybe there are more than two objects which are involved in the particular fact. Number one, identify those facts. Number two, try to find out what relations they have. So sometimes you might have a single relation and you might have more than one relation which are being there in the sentence. So you have to identify those relations. And then in the third step, please see that whether the given statement or the given objects are referring to can be represented as for all, or they might be represented as existential quantifier. So that can also be easily understandable while we are dealing with the sentences. And fourth step is that how you will make the predicates. So the relations which you have selected, try to convert them into predicates so that you can represent those sentences. You can see now the first sentence is the brothers are siblings. This is true. Brothers are siblings. This is true. And there is no need to write all brothers are siblings. There is no need to write this statement. This is wrong. Brothers are siblings. Yes, this is true. This is universal statement. So whenever we have a brother relationship, always remember you try to find out the object. So brother relation is normally divided between two objects. किसी भी दो objects के दरमियान हम देखते हैं ना कि brother relation है या नहीं है. Similarly, the sibling one also. So it means we are talking about two objects. One is x and one is y. So you can write in that manner also for all x comma y. You can either write for all x, for all y. Both are true. For all x comma y, brother x comma y, y, because they are brothers. Implies they are also siblings. So sibling x comma y, that is the representation. The other sentence is the sibling is symmetric. Yes. Any relation which is symmetric means that if you change the argument position, it does not matter. For example, brother x comma y is equal to brother y comma x. Does not matter if you change the position of y and x. Similarly, sibling x comma y is equal to sibling y comma x. Yes, because they are symmetric in nature. But all relations are not symmetric. For example, if there is an expression greater than x comma y and you change it to greater than y comma x, this is wrong because this is not symmetric. For example, if you have a relationship father of x comma y, so y x is the father of y, and if you change the position and you take y first and x afterwards and you equate them, this is wrong because this is not symmetric. But here the brother relation itself is a symmetric, and this sibling is also symmetric in nature. So for all x comma y, sibling x comma y, biconditional sibling y comma x. Now you have another statement which is a difficult statement. That statement is one's mother is one's female parent. Here we are talking about two objects. The object which we are referring jiski mother hai, and mother itself is an object. And there are various relations which are involved. One is mother, one is female, and one is parent. So for all x comma y, mother x comma y, and mother is x right now, y is the child. So for all x comma y, mother x comma y, biconditional female x, that x is a female and also a parent of y. That statement is true. Now these are the representations in FOL. So whenever you have the given statements in English or in natural language, then try to convert those statements by following a procedure. Not try to translate them like you translate from English to Urdu or from Arabic to Urdu. No, this is not the way you write FOL statements. You have to write those statements by considering that is there any constant which is involved, is there any variables which are involved, how many variables are involved, how many objects are involved, what relations they have, which predicates to be formed, which quantifiers will be used, which connectives are required. Then you can see that whether the sentence which you have created is whether it is true in the given situation or not. That is the way you can write the FOL statements. And there is an exercise at the end of the chapter. There you have been given various sentences, and please try to solve every sentence so that you should know that how to make an FOL statements. Because by going through the lecture, it looks easy, but whenever you are dealing with the problems, there you will find it difficult how to represent in FOL. So as much as practice you do, you will represent in a better way. So with this, I conclude over here, and I hope that you understood the lecture, and we will continue our lectures from next week. Thank you.